Bismillahirrahmanirrahim. In this unit 6, we will discuss about Fourier transform. Now question arises why Fourier transform is so important and what is the role for the communication system. We will discuss these two questions in this unit 6. Fourier transform is a cornerstone of communication system enabling signal design, analysis, and optimization. Its ability to bridge time and frequency domain make it indispensable for understanding and enhancing modern communication system and technologies. In the previous unit 5, we explore and discuss the Fourier series. Now we are going to discuss another mathematical model such as Fourier transform of the signal process in the communication system. Still, it is a part of chapter 1 as a unit 6. Fourier transform is not just a mathematical tool. It is a cornerstone of modern innovation. From your smartphone to space exploration, it is quickly working behind the scene, making the impossible into possible. So, the next time you enjoy seamless video streaming or crystal clear phone call, remember that Fourier transform and its profound role in connecting our world. Fourier transform can be defined as a time domain signal xt. The Fourier transform xf is defined as that xf is equal to integration from minus infinity to plus infinity xt e power minus j pi j2 pi ft integrated with respect to time response. Now we define each component here. Xt, the time domain signal, xf, frequency domain signal, which is the purpose to convert time domain signal into frequency domain signal. Here f is frequency in hertz, j is a imaginary unit to represent a complex variable. Signals in communication system are often analyzed and processed in frequency domain because many operations, for example, filtering, modulation, are very simple in frequency domain. Signal characteristics like bandwidth and frequency contents are easier to interpret. However, the real world analysis of the signal are typically in time domain. For example, voice, video, data, etc. So we use the inverse Fourier transform. We rep simply IFT. The IFT is needed to convert process signal back to their time domain from the transmission or playback. Enable end user or device to interpret the signal in its original form. Xt can be calculated, which is in Fourier inverse Fourier transform. Xt is equal to integration from minus infinity to plus infinity xf multiplied by j e power 2 pi ft and integrate with respect to frequency domain. The difference between Fourier transform and inverse Fourier transform is that in Fourier transform it is xt and e power minus j 2 pi ft, while in inverse Fourier transform it is xf and multiplied e power j 2 pi ft and integrate with respect to frequency domain. Let's discuss the signal and explore why spectrum analysis, signal transmission, filter design, and modulation are critical to modern communication system and how they are all connected by the Fourier transform. First, spectrum analysis, every signal we encounter, whether it is your voice or phone call or song, you are streaming as a unique composition of frequency by analyzing these signals using the Fourier transform. Engineers gain a clear understanding of the signal structure and energy distribution. This insight is essential for designing efficient communication systems and understanding noise, interference, or distortion in the real world application. Now, signal transmission, the communication based band signal often needed to be converted to high frequency known as passband signal for efficient transmission over a long distance. This is why Fourier analysis come into and it allows the transform and optimize the signals and ensuring they can travel across various medium such as cables or wireless network without losing quality or clarity. Moving on the filter design, filter are indispensable tool in communication used to extract or suppress a specific frequency component from the signal. For example, when you are on phone call, noise cancelling algorithm rely on filter to block out background noise, leaving only the desired voice signal. The Fourier transform is critical here, enabling engineers to identify and isolate unwanted frequency for removal. Finally, let's talk about the modulation and demodulation. These processes allow us to transmit data over long distance efficiently. Technique like amplitude modulation or frequency modulation modify a carrier wave to encoding information. Fourier analysis and transform provide the mathematical framework to understand and optimize these techniques, ensuring signal and transmitted and recovered accurately.